Welcome back to another session of emulsion making and coating. This section is devoted to the various methods of washing emulsions. We'll be going into a lot more detail in this section, and you'll see a lot of different techniques. Most of the thrust of this, though, will be on ultrafiltration. First off, when we go back to the very early days of emulsion making, emulsions were noodle washed. Basically, they used a potato ricer, which you can get at your local grocery store or at Bed Bath & Beyond or someplace like that. You place chunks of your emulsion in here, you put the plate in, and then you close the ricer and squeeze into ice-cold distilled water. And these noodles, which look very much like large spaghetti strands, are then washed in the cold distilled water. To keep them collected together, you usually use cheesecloth. However, I take the poor man's approach and use an old pair of pantyhose. These are not mine, by the way. But I use an old pair of pantyhose, let the emulsion go into it as it's noodled, and then I dip this into a can of distilled water. Now, the important thing to remember is that noodle washed emulsions always swell and become less concentrated. So therefore you lose control of the concentration of the silver in the final emulsion. It always goes down, which means lower contrast, lower Dmax, and lower speed. To counteract this, in the early days, they used to use what we called at Kodak sweet water. This was water which had a fair amount of calcium sulfate in it, and it washed out the silver halide, it washed out the excess halide and nitrate ions. This worked very well, but left behind sulfate ions. So it had a moderate degree of success, but it was used. In an earlier portion of this series, we showed you iso washing. That was the second method used in washing emulsions. Iso washing used a special type of gelatin called phthalated gelatin, and when it's acidified, it either forms a gooey material somewhat like silly putty, or it forms a flocculant that settles to the bottom of the beaker. I prefer the goo method myself because it's faster and it's more concentrated. The other method, the flocculation, takes a couple of hours for the settling to take place. In this method, you virtually squeeze out all water, and then at the end, you can dilute it with any amount of water you want and get the concentration you want. At Kodak, when we started to use this method, most all of our emulsions were made to a standard weight of 1 kilogram per mole and 10% gelatin. Now I know it varied a little bit around that point because it couldn't be exact, but that was what the aim point was. Now what you sacrifice is that you have to buy a special gelatin. You have to know what percentage phthalation you want, and you also have to remember that when you phthalate the gelatin, you change its coating properties and its hardening properties. So these two methods were the two earliest. You have seen the phthalated version, the iso washing, demonstrated in another portion of this tape, and in the textbook you see still photographs of my friend Mark Osterman, who supplied me with pictures showing how to do the noodle washing. Currently, production emulsions at Kodak are washed using ultrafiltration. Ultrafiltration units come in two different types: the plate and frame and the hollow fiber filter. These are spiral wound. You have to base the type of filter you use on the amount of emulsion you're making, because at the end of the process, some emulsion will be retained within this unit. This unit retains 15 milliliters, and this unit can retain as much as 1 full liter, which makes it uneconomical for small batches. This is a standard hand-pumped water purifier used by campers to purify water from lakes and streams while they're out in the wilderness. I use this to illustrate a plate and frame ultrafiltrator. You pump the water through here, and the water is purified by virtue of the fact that the dirty water diffuses through the membrane. Clear water comes out this way, and bacteria and dirt are collected on this surface. With an ultrafiltrator, you want to collect the salt coming out here, and you want to collect the emulsion both. And that's the major difference between the two. In order to supply the hand pump power for a UF unit, you need a pump. The pump has to be capable of delivering at least 60 psi, and the tubing you use has to be able to accept that pressure and a temperature of about 110 degrees Fahrenheit. This millipore Pelican unit is a plate and frame UF unit that has one feed port, one exit port for waste, which must be measured, and one return line which goes into the source container. So at 50 cc's per minute, if you have 200 cc's of solution, it will take 4 minutes for one turnover. That is, in the time of 4 minutes, all 200 cc's will have flowed through this unit. And you must have tubing that is capable of accepting the pressure of 60 psi and the temperature of 115 degrees. These units are always stored sealed with a preservative solution in them. And at the present time, I'm removing the seal caps and putting them into a container for storage. Since the input is coming as hot water, I screw in a special stainless steel connection with high pressure polycarbonate tubing so that I don't spring a leak, because an alternative which used low pressure polyethylene swelled up to about the size of a large apple. All of the connectors are quick disconnect, and so I can push this in all the way and it seals. The next connector can be soft plastic because it will have no pressure on it, and it will go into one of these exits and the other one will go into the other. I have now connected an input line into the input port of the pump, a high pressure output line to the millipore unit, and 2 low pressure lines to the exit ports. I have to purge the preservative solution while at the same time bring the filter up to an appropriate operating temperature. The Pelican unit, once it is set up, must be purged of the preservative solution and also brought up to the correct operating temperature, which is about 105 to 110 degrees. And it should be run at approximately 60 psi. This pump will oscillate because it is a diaphragm pump with what's called a knuctating membrane. That is a membrane that moves back and forth, sucks in and pushes out. Once this is running and you've got hot water going through, you then start to run hot distilled water through. And so you change the line over to distilled water. so you can purge the unit with tap water. Now, every time you move the line and you get an air bubble, you will get a drop in pressure, which will then rise back up. And if you looked closely, and that was in camera view, you saw the pressure drop and rise as I changed it over. If you look at the exit ports, you will see that this is the waste, and that is wastewater that's coming out. And if this were salt water, I would be getting distilled water out of one line and salt water out of another. It would be purifying the water. What we want to do is measure that with a graduate cylinder. I have here melted 200 grams of azo-type emulsion. The pump is running at about 50 cc's per minute and approximately an average of 50 psi. I can adjust it upwards with a tiny change on the potentiometer. And now I'm ready to go. I shut the pump off, go dark, and begin the process. We're now ready to begin ultrafiltration of an azo-type emulsion. We have one line that sucks the emulsion out and puts it through the pump. The pump puts it out through a high pressure, high temperature line into the filter and then runs it out through two lines. The waste goes to a graduate cylinder where we measure the waste, and we also test it for the amount of salt present, because as the salt decreases, the silver test for salt will become lower and lower. And the third line coming out returns the emulsion into the original can. So now I'm starting it. And you can see the emulsion, the opaque emulsion running up through the pump. And now you can see the emulsion start to come out at the other end. Very slowly. And there are no leaks. And now emulsion is going through the return line, but you notice here that this line is free of emulsion. Now if we can look over here, this line here is demonstrating a slow but real flow of water plus salt. That is washing the emulsion with 100% retention of the emulsion. And if we let this go for 4 minutes, that should be one cycle. If we let this go for 8 minutes, that's 2 cycles. And usually collecting about 20 milliliters of clear salt solution is enough. If the collection rate is not high enough for your taste, I'd like to show you the little clamp that comes with the kit that you clamp onto the output line of emulsion. And what it does is raise the pressure ever so slightly in the permeation line, which is the salt flow. So you can actually increase the rate of washing by increasing the pressure a tiny amount. At the present time, this pressure is over 100 psi, and so I'm going to have to slow down the rate because I don't want to burst the membrane. As long as the average temperature is 105 degrees and the average pressure is 60 psi, the system will perform as designed. What happens very gradually is that the material begins to plug the pore. Still flowing, but at a much, much reduced rate to prevent bursting of the seal. There is still material coming dropwise out of both of these tubes. You can see the flow. This is now running at approximately 25 cc's per minute, and so this would take us probably 10 to 20 minutes for a turnover, and I would say maybe a half hour to wash. I have removed the line from the emulsion because we have collected 20 cc's of solution, and I am now clearing the lines with distilled water at the volume of these lines and at the rate that it's flowing. It will take just a few minutes to clear the line of emulsion. Oh, we're not getting anything flowing here. So I'm going to up the speed just a tad. There, now we're starting to get water flow in the line. And once about 15 to 20 milliliters have flowed through the lines, you can see the line is clear up to here. So we've actually flushed the emulsion out. We will not be able to see emulsion in the opaque high pressure tubing, but we will see it begin to flow over at this end. And since the emulsion has been flushed out, the pressure has dropped because there is no plugging. The hot water has flushed it out. So you see here, completely clear tubing, and at this point we are starting to run some clearer and clearer material through. There it goes. It's clear now at this point. So I'm going to sacrifice approximately 10 cc's of emulsion. That'll be trapped in here. Okay, now I take these lines out. I show you that we have collected 20 cc's of water and or rather 20 cc's of salt plus water, and another about 8 cc's of plain water as I washed it out. That would test as having a lot of sodium chloride in it. Now what I'm going to do is simply wash the lines at high speed, and you see over here the last little bit of emulsion that's being sacrificed. Approximately the 15 cc's that was trapped inside the millipore unit.